Welcome to the AP Calculus BC video for skill number 218. I can use limits to define the derivative of a function f at a number a and use this in problems of position and velocity. Alright, now we're really getting into some stuff that's calculus related, and the first thing is we should be able to find the tangent line of a curve at a point P. And we can do that by finding limits. So the slope of the tangent line is defined as the limit as x approaches a of f of x minus f of a all over x minus a. And you can think of this as we have a curve and we found the slope of the secant line from x to a. And we're taking the limit as x approaches a. So x is getting closer to a and even closer to a until x and a pretty much share the same spot. And that's going to be the slope of the tangent line, provided that this limit exists. So let's see an example. Find the slope of the tangent line of y equals 3x squared at the point x equals 3. That means what we want to do is take the limit as x approaches a, so the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. So I write in my f of x, I subtract f of 3, we evaluated f of 3 to be 3 times 3 squared plus 1 equals 27 plus 1, which equals 28. All over x minus 3. We simplify the numerator, and as it stands we can't calculate the limit because we get a 0 in the denominator. So what we want to do is, actually we have 0 over 0. So then we factor the numerator. First I factored a 3 out and I got 3 times x squared minus 9. And then I saw that perfect square binomial, or sorry, the difference of squares binomial, so I translated that. My x minus 3's cancel, and now I'm evaluating a limit that I can do by direct substitution. Plug the 3 in, and I get 3 times 6, which is 18. So the slope of this curve, 3x squared plus 1, which looks something like this, very steep parabola, at the point x equals 3, probably somewhere around there, the slope at that line is 18. More commonly we'll be asked to actually find the equation of the tangent line. So we'll use the same process as before by first finding the slope of the tangent line, and then we plug it into our point slope equation. So in this case we're finding the slope at x equals 1. So we do the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. So we plug in our f of x, which is 2x squared plus 4. Then we evaluate f of 1, which we find to be equal to 6. And if we simplify the numerator, we have 2x squared minus 2 over x minus 1. And to evaluate that limit as x approaches 1, we have to factor again and cancel out of the top and bottom, giving us 2 times x plus 1. That limit is equal to 4. So now we know the slope of the tangent line, we just need to find a point on the tangent line. Well, we already know that it passes through x equals 1, and if it touches the graph of the curve, we can evaluate f of 1 by plugging 1 in there, and we get a point on the line as being at 1, 6. Now that we have a point and a slope, we can plug it into the point slope form. So we plug in the values of 4 for m, so we found the slope to be 4, so we can plug that in, and then our point occurs at 1, 6, so we plug in 1 for x1 and 6 for y1. And we now have an equation in point slope form of the line that is tangent to the curve at the value x equals 1. Moving on to page 218C, we are going to define the derivative of a function, which is denoted f prime of a, and that is defined as the limit as h approaches 0 of f of a plus h minus f of a all over h, if the limit exists. So we've now got two different ways to define the derivative. The slope formula that we had just shown, and then there's also this formula. So using this formula, we're asked to find the derivative of f of x equals x squared minus 3x. So we're going to scroll up, and we remember that the derivative, we're going to find it in terms of a, f prime of a. So f of a plus h minus f of a. We plug a plus h in for the variable, minus 3 times a plus h. And then we do minus f of a, which would be a squared minus 3a. If we expand out the top, we take our binomial squared and write it as a trinomial, 3 times a plus h, and then we can distribute the negative, and we get this long thing in the top, long series of terms. We can start canceling out like terms, a squared minus a squared, negative 3a, positive 3a, and we're left with 2ah plus h squared minus 3h in the numerator, which if we wanted to, we could factor to be h times 2a plus h minus 3 all over h, which allows us to cancel the h's so that we can then evaluate the limit. We take the limit as h goes to 0 and find that the derivative of f is 2a minus 3. So f prime of a is 2a minus 3, which means at any point on the curve we can find the slope by plugging in the value for a. So if I wanted to know what the slope was at a equals 7, I would say 2 times 7 minus 3, which is equal to 11. So on that curve, the slope at a equals 7 is 11. We can apply this to instantaneous rate of change, because the derivative is just another way of saying instantaneous rate of change, which we'll see in the next example. So instantaneous rate of change is when you take the limit as your change in x goes to 0 of delta y over delta x. Alternatively, you could say the limit as x sub 2 approaches x sub 1, and this is kind of your secant formula. More simply, we should, and most commonly, the instantaneous rate of change at a value is f prime of that value. So we can use whatever definition for f prime that we want. In the problem below, I'm going to use our limit as h goes to 0 definition. So a particle's displacement in meters is modeled with s of t. Find the particle's velocity at time t equals 0. So basically what they're saying is find s prime of 0. So the approach I took was I first found s prime of a, and then I plugged 0 in. So s prime of a, we use the definition of the derivative being the limit as h approaches 0 of f of a plus h minus f of a all over h. So I plug that in, 30 times a plus h squared minus 5 times a plus h plus 1. So there's the first piece, f of a plus h. and then we subtract from that f of a. And then I did all the counseling off screen, but in the end we wind up having 60ah plus 30h squared minus 5h all over h. And if we cancel an h out of the numerator and denominator, we get the derivative of s at a to be 60a minus 5. And we wanted to evaluate it at 0, so we plug 0 in and get an answer of -5. Which means the instantaneous rate of change, or instantaneous velocity, is -5 meters per second. Alright, this concludes skill number 218. Thanks for watching.